So, and thank you for the introduction. So today I'm going to talk about something which is not really related to Gen AI. It's something that I have been working for a long time, and despite these systems being fairly mature, I think there are still things that you have to, or mistakes that you have to avoid, which I, by the way, did while I was working on these systems. And hence I wanted to tell you about what those lessons are, right? So that's what the talk is about. So a couple of caveats. As I said, it's not about Gen AI, but the other thing is it's not also about for projects which are one-off, right? This is for long-term initiatives. Think of multi-year initiatives for both of these problems, and many of the learnings are not necessarily that you apply on day one, right? These are things that you have to do over the course of the time while you are working on these, right? So the first learning, right, and this I think is the most important thing I consider for all these kinds of projects, is you have to really nail down the metrics. And while metrics are everybody thinks about metrics, right? You might think about what are you going to improve with your rexes, right? You might improve your conversions, click-through rate, and things like that. Those are called the goal metrics, right? But some of the other dimensions that you have to think about are what I call, or what is called, the guardrail metrics, right? And these are the metrics that are not necessarily the goals of your system, but they are the ones you don't want to really mess up with. For example, it could be the traffic distribution, the diversity of the content, or the freshness of the content, right? And then there is another set of metrics which is not really very commonly kind of thought about, which is called the debug metrics. And these are the metrics really by themselves, they don't really tell you much, but when you contextualize the goal metrics or guardrail metrics together with these, they will allow you to debug your system very quickly. As an example, in case of search, number of searches per user is not a metric you want to go up or down by itself, but you have to look at it with the context of how is your CTR going up or down, right? You have to think about the time horizon, long-term versus short-term metrics. You also have to look at what are your business level metrics, what are your system level metrics, and what are your model level metrics, right? You can't ignore any of these, and that's why it becomes very tricky to kind of think about all these things together. And then the last one, which is even the trickiest part, is what is called the overall evaluation criterion. This is the one single metric that you will use to figure out whether your system is successful or not. And because you have a bunch of metrics that you have thought about, this is again very hard to create, but it is critical that you create it, because once you launch the system, everybody is going to look at this metric and say whether you are successful or not. Now, the second set of learning is about the data bias. And most of you would have heard about biases in the data. Even things like ImageNet data set also has biases, right? But especially for search and recommender systems, these biases are very pronounced, and if you ignore them, your system will definitely go into what is called a feedback loop, which means it will just recommend the same stuff again and again, right? And so some of the biases that you have to kind of think about is, one, selection bias, the other is position bias. And while there are ways to kind of deal with these biases, you can create these unbiased versions of models. It is not very straightforward, and you may have to implement these algorithms yourselves, because there are not many battle-tested open source implementations available which you can readily use. So that's one of the challenges. The other thing is, to avoid these biases while collecting the data itself, you can actually add some kind of exploration component which will kind of expose content which has not been previously exposed, even when it is not the best content to be exposed. The third one is about training data and features. Now, for many problems, it is very obvious what your training data should be, and in terms of feature, you always have to think about it. But in case of especially search and recommender systems, it's not very straightforward all the time what your training data should be, and you have to think about it a lot. But some of the things that you can keep in mind to make sure that you are training on the right set of data is, if your system is already mature and you are not bootstrapping, then you should train using already collected data, which is the logs, where all the feature values are also already logged. The other thing that you can do is, improve the quality of your data. And by that I mean, these systems typically are trained on billions of records, but not necessarily all of that data is useful. You may have to do some kind of a duplicate removal, which is again not a simple duplicate removal. You will have to think about what are really the duplicates. You may have to sample, because if you are training your models on billions of records, and typically these have to be retrained very regularly, you will run into problems of not only having too much of training time, but also the training cost. And so you may have to sample with importance bias, importance weights. The other important thing that you have to think about is positives and negatives. In case of many problems, for example, let's say fraud detection and all, what is your positive and negative sample, right? Fraud is positive, not fraud is negative. In case of search and recommenders, it's never obvious. In fact, the negative samples are the trickiest part of these systems, where you may have to kind of create a strategy where you take randomized negatives, as well as you have to mine for hard examples that the system cannot learn from, but you still have to put there so that the system can actually make sure that it has paid enough attention to those kind of samples as well. In terms of feature, couple of things I want to call out. You have to be very careful about features which have a cold start issue. What I mean by that is, a feature like historical CTR of an item, of a product, is a cold start feature. Why? Because if an item has never been exposed, you cannot calculate its CTR, but you still need it. So you have to have a strategy to kind of initialize those features well, or you should just completely avoid those features. The other important thing is, you should always prefer interaction features over item only or user only features. Now, what is an item only feature? Something like price of the item, or length of the title of the item, or user's age, right? And why? Because the relevance of an item is always in the context of the query, and for certain queries it may work, or for other queries it may not work, if you just keep in mind the item only feature. Next one is, when you create these models, you have to kind of understand how they are performing even before you deploy them in production, which is called the offline evaluation. And there are many pitfalls in this kind of a thing as well. First one is, thinking about the metrics which are really already established. NDCG is something like that, which is like a standard metric that is used, and people don't even think about whether it will apply to their use case. Many times it doesn't. For example, if you are showing only 4 results to a user in terms of your mobile screen, NDCG at 4 doesn't make any sense, because there is not much of a ranking going on there. The other thing I have seen a lot people doing, data scientists doing, is having some kind of issue while they're splitting the data in terms of your training, validation, test set. This is very important. Even many of the papers that you may have read have this issue where they could do some kind of a randomized split or some other somewhat different flavor of randomized split which has leakage in it and can give you a false sense that the system is working better than it really is. And the last one, which I think it doesn't get enough attention, is not only you have to evaluate these systems by calculating these metrics through your code, but you also have to expose these to humans before you launch them. And that needs a little bit of effort. You may have to really work with your stakeholders like product management to establish processes around that, ownership around that. You have to refine the guidelines. What does it mean to have a good result, right, in terms of a recommender system? And those guidelines have to be clear enough that so that you get usable data. And then the last one is, we all say dog fooding is good, which essentially means your own, employees are looking at these systems and telling how good or bad they are. But then employees are not the typical users, and hence what you have to do is you also have to somehow source feedback from outside. Now, the next one, which is like the holy grail of all these systems, which is called the online and offline gap. What does it mean? I think anybody who has worked in search or recommender system knows this, that if your model is working very well in offline doesn't mean it will actually work well when it goes in production. And the reason for that is your data on which you are evaluating is already biased, and it is going to give you something which is more optimistic than it is. And so you have to really think about this before you launch and really avoid the sort of temptation to optimize for only offline metrics, because that probably is not going to pay off, because once you launch the model, you will know what the real performance is going to be, which is not going to be as good as what you saw in the offline world. Now, there are ways to avoid, that trap, where you can actually use something what is called the off policy evaluation, where you can debias some of this evaluation as well. But the same caveat goes, there are not many open source battle tested implementations where you just say, oh, here is my data, I will just change some of the things and somehow it will give you results. It's not like running a XGBoost or LightGBM model where data goes in and you get something out, right? So you may have to really do this. In fact, many times me and my team have implemented some of these algorithms ourselves. The next one is about retrieval. I think for all these systems, there are two parts to it, right? One is called the retrieval or candidate generation. That's the first stage, where you sort of look at millions of items and then take out maybe 1,000 or maybe 10,000, depending on what your requirements are, which are the best ones. That's called the retrieval or candidate generation step. And then those 10,000 or 1,000 or 500, whatever it is, you pass through what is called a learning to rank model to show the best set of results in a descending order. If you screw up that first stage, which is the retrieval step, then there is no recovery from that, because however good your ranking algorithm is, it cannot really fix the issues of omission, which means if a result is not there, a good result is not there in your retrieval set, a ranking model cannot fetch it. It will just rank whatever is already there. And so you have to be very particular about measuring this step properly. And this is hard, because if you have, let's say, 100 million items or 200 million items in your inventory, like we have at Poshmark, there is no way you can really say out of these 200 million items, which are the truly relevant items for any kind of query. Say I say Nike shoes. There is no way you can tell me there are these 1,000 or there are these 5,000 items which are truly relevant. And if you don't know that number, there is no way you can calculate the recall, right? So recall at K is a metric that people use, but then it's not really the correct metric. Or rather, it doesn't give you the right picture, because the true relevant set is never known. So what do you do about it? You have to look at some other metrics, right, which are One of them is called retrievability, which kind of flips around the recall on its head and looks at it in a different way. And if your query set is small, then this metric is much easier to calculate and still gives you the right picture. Then there are other ways you can be creative to find out how your retrieval step is going on. One is you can actually use a ranking model to tell you how your retrieval is working. So what you do is you take your candidate set, pass it through your ranking model, find out what is the average score, and the higher that average score is, better your retrieval is. It doesn't tell you actually how in percentage what the recall is, but it can actually help you decide which retrieval set is better than the others. And the other one is you can actually create something like a unit test. People who have worked in software engineering would know this. These are smaller, obvious kind of tests that you create to tell your software is working well or not, right? So as an example, in case of let's take an example, Twitter, right? If people sitting here, let's say, are seeing recommendations of users and tweets which are from France, that's not a good retrieval mechanism because it's showing completely irrelevant stuff to most of the people here. This one probably relates somewhat to the Gen AI kind of discourse. So I have been we have been sort of playing around and deploying some of these vector-based search applications. One of the things that we did was we deployed a visual search feature almost a year back where we are using vector search. But what we found out is vector search is not the silver bullet that people think it is. And what I mean by that is some of the, how Google used to work and still probably does. It uses the keywords from your query and the documents to kind of do the matching, as well as Google has its own ways of, doing PageRank and whatnot. But the keyword-based search or lexical search as it is called is still hard to beat. And the other thing is if you combine lexical and vector-based search together, it becomes even harder to beat, right? And that's the kind of the state of the art right now, at least for search, is the hybrid search, which is vector plus lexical search. And so you have to kind of, look at this instead of looking at vector search as the standalone solution. The other thing that is related to infrastructure is when people think about vector search, they just think about the vector DB or vector store. They don't think about what is called a search engine, which is like the full-fledged kind of infrastructure to power your search and recommender systems. Something similar to Elasticsearch. There's another open source project from Yahoo, which is called Vespa. And you have to look for those kinds of things rather than looking at vector DBs like Milvus or something like Quadrant and things like that. Why? Because these vector DB just let you do the approximate nearest neighbor search, and none of the other things like facets, filtering, all of that is available in those, at least right now. And the last one is, although I think LLMs are a kind of a game changer technology, they still have not solved for the information retrieval part of it, which means you can't really just replace the full search experience, at least on some of the domains like e-commerce, by using a large language model, right? You have to really still use components from the traditional IR, which is lexical search, and even some of the vector-based search to find out what is your really true relevant set of results and then rank them. So LLMs probably will get there, but not yet. This one is about the experimentation. I think many of you would have rather either run the A/B tests or at least studied them. And so experimentation is typically done for finding out what is the impact of your feature on your business metrics and all. but the other way to use that is, in fact, guide the development of your models and systems as well. What I mean by that is, when you are, for example, building a model and you don't know whether it is really doing what it is supposed to be doing, you can really run a very small A/B test to just find out whether it is really directionally doing that. That does not mean it will deliver the impact that you probably are thinking about, but you still learn that your algorithm is doing what it is supposed to be doing, and then you can kind of build on top of it to figure out what the next steps could be. Things like you have to think about, what is the impact of accuracy versus latency by doing certain kind of, sophisticated A/B test designs, right? And then there are other things that you have to think about, which is called the network effect. In case of a marketplace, you have buyers as well as sellers, right? Similar to, many of the apps that you use, there are two sides to any kind of transaction. And there are network effects going on, which means if you constrain one side, you can't constrain the other side, because otherwise you can't even run the marketplace. And you have to think about that while you are running your A/B tests. This relates more to a non-technical thing, which is if you are making big changes to your search or recommender system, you have to really think through your go-to-market plan, which means you have to tell your users what you are doing without revealing too many details. As an example, when Google changes their search algorithm, they upfront tell you that these are the things that will happen without telling you the full details, because they want to make sure that certain user segments are not negatively affected, right? And they also would come up with, policies that you need to kind of keep in mind. When any change happens on algorithm side, the users will kind of try to somehow negate that change, especially those ones who are not the good users. And you have to create and modify your policies so as to take care of those kinds of things. This one doesn't need any repetition, but I will still repeat, which is simple things can provide a lot of value. And here I think things like, I'll give you an example. We created a pre-ranking model which had just 2 features in it, and it gave us like a double-digit boost in terms of GMV. How many iterations did we go through this? We had to create like 25 versions of this model before we actually went with this model. And so what my point being, simple is, sometimes very valuable and, impactful, but it also is not always easy. You have to probably think harder to get to a simpler solution. Even for something like collaborative filtering, there have been algorithms which have which have come up in last couple of years, which are very powerful. And before you do something fancier, you can just replace simple collaborative filtering with these kind of algorithms to take care of many of the issues. Now, another thing that many people like is bandit algorithms. These are fancy algorithms, but if you launch them, many things become very complex, including your training as well as monitoring. And so before that, you should try to, extract the most out of whatever techniques you are already using. This is more around those, the guardrail matrix that I talked about. This again gets ignored a lot. So diversity and fairness. Diversity is known to have this highest correlation with the longer term success of any of your recommender system metrics. And the fairness is very important. If you want to make sure that only a certain set of sellers or users still get the exposure, right? You have to kind of balance it out and make it fair for everyone. So you have to think about both of these from the beginning. If you launch without thinking these, then what ends happening is business is always going to talk about the goal metrics, which is GMV, revenue, conversions, and they're not gonna put this on the roadmap in the near future, and that means you are going to lose out on the longer term effects of your system. This is more about the infrastructure and processes part. This is not about the infrastructure that needs for your model serving itself. This is about some of the peripheral infrastructure. For example, you have to create monitoring systems, you have to create a good incident response management system, you have to log everything so that you can use that to debug the systems easily, because imagine your search system is serving tens of millions of requests every day and is responsible for maybe 50% of the revenue that your site is generating. If things go wrong and you don't know where to look at in terms of logs, you are in trouble. And so you have to really do that. You also can actually create an infrastructure to run these models and systems in a shadow mode. What that means is, shadow mode essentially is you can run production traffic to the system, but none of the users are going to get impacted by this. So you get a full view, end-to-end testing of the system without affecting the users anyway. And once you're sure, you can actually launch it to everyone. This is more around the QA part of it. I think everyone who has worked in software engineering knows that there is a separate QA team which typically does all the testing for you. But for these systems, it's not as mature. So you have to really think about this as well and create processes around that. You have to really look at even the small things, like sometimes these bugs are so silly. As an example, one time we deployed a model, and while doing the handover, somebody sorted the results instead of descending, they sorted in ascending order, which meant that users were seeing the most irrelevant results at the top, right? And things like that can also happen, and you have to really test for that. You have to make sure that the model that you think you are deploying is actually running in production. One time we thought that we have deployed a new model and it was never deployed. You have to clearly define what your owners are in terms of testing, and again, like I said, run it in shadow mode to find out if the system is working properly. And then the last one, which is really important again about the people and organization, is none of these initiatives, if you are serious about it, can be done in 3 months or 6 months. These are multi-year initiatives. You need to have a dedicated team, a cross-functional team, and there has to be a real executive sponsorship for that, where the team doesn't get reorged or changed too often, because that will really always make your roadmap slower. You also have to communicate a lot with your stakeholders. Given that these are long-term projects, sometimes what you thought you are doing and what the executive leadership wants become divergent, and you have to realign those together. Otherwise, you are headed for a sure shot failure in terms of when you actually launch the project. And then the last one, which is very I think peculiar phenomenon with search, is once you launch such an initiative, everyone in your organization will start looking at how your search results look, and they will have an opinion on, oh, this doesn't look right, this is like this result is like really irrelevant and things like that, and they will keep you pinging, oh, this is not working, this is failing, why is this doing that? And while it can be really sometimes irritating to get that much feedback, I think it's also a gift where you can collect all that feedback in a very process-oriented manner, in a structured manner, and then harness it to kind of create changes to your roadmap so that you are actually using that feedback to improve your search systems. So I think that's all I had. Just in the spirit of the conference, Gen AI spirit, I just created this one last image using DALL-E. So that's all I had. I hope this talk was useful. And if there are any questions, I'm happy to answer them.
Hi, excellent talk. I wanted to ask, or rather, could you please go a little deeper into the methodological flaws that you talked about?
You're talking about the train test split, that one. So one thing that happens is, imagine you have a set of interactions, right? In case of recommender system, you may have like users and items, and then what was clicked or what was not clicked, right? And typically there is a timestamp attached to it when this happened, right? Many times what happens is, people tend to do a randomized split, right? If you think about it, this is not a data set at one ID level, it is at a 2 ID level, which is your user ID as well as the item ID, right? So what people tend to do is they will split it using just the user ID in a randomized way, and what that does is creates a I would say boundary between your train and test set, which is different in time for different users. So as an example, for you it might get created between Jan and Feb. For me, because I haven't interacted much, it might get created between something like last year's September and October. What that does is, some of the items that you have seen were never there for me to see because they are in the earlier past, and that creates what you call the leakage, because system now knows these items are going to be there in the future, which shouldn't be available as a knowledge to the system, right? And these are the flaws. Some of these flaws are present in papers as well. Recently there was a paper in I think SIG-IR which talked about these methodological issues even in the research papers, right? So the correct way to do it is, for everyone you have to decide a boundary in time. Imagine between Jan and Feb. Just everything before Jan becomes a training set and everything after becomes the test set. All right, thank you.